Our project, which is an office printer buffer with shortest job first scheduling algorithm, will be presented by Rami and Goh Chang Zhe.
Hi Dr. Fakana, my name is Goh Chang Zhe and I'll start my presentation by presenting the abstract of this project. In a typical office, printers receive many print jobs with different page counts, often causing delays when large jobs block smaller ones. To solve this, we use the shortest job first scheduling algorithm, which prioritizes jobs with fewer pages to reduce waiting and turnaround time. We simulated this using C programming language, where each job gets a burst time based on page count and is scheduled using non-preemptive shortest job first algorithm. The output includes job ID, arrival time, pages, start and finish time, waiting time, and turnaround time, showing how shortest job first improves printer efficiency. This is the introduction of the shortest job first algorithm project. Efficient scheduling is crucial for shared systems like office printers. When multiple print jobs with different page counts are submitted, poor scheduling can cause delays and reduce productivity. To address this, we used the non-preemptive shortest job first algorithm. Shortest job first reduces waiting time by prioritizing the shortest job. This project applies shortest job first to an office printer's buffers to optimize job handling and improve overall efficiency.
Assalamu alaikum. So the problem statement behind our project is that first come first scheduling algorithm is being used in the printer buffer system, which can cause a lot of overheads and waiting time. That's why we and it doesn't have any prioritization algorithm or mechanism to prioritize important jobs over the others. So that's why we addresses this problem in our project and introduce a better scheduling algorithm, which is shortest job first. This algorithm prioritizes jobs by the shortest job and give them a higher priority. So the objectives are to display scheduling results in a tabular format and showing ID, arrival time, etc., and implement a non-primitive shortest job first scheduling simulation using C. For the related works, shortest job first is widely being used in the industry as it offers better waiting time and turnaround time than first come first serve, and it is being adopted widely. And in this project, we make use of this scheduling algorithm with simulation being based in C++ program.
This is the project management flowchart of our project. In this project, we follow a linear and iterative process, starting with the project planning to define the problem, scope, and the objectives. Next, we conducted a literature review to understand the shortest job first scheduling algorithm and its real-world use. Next, we designed the algorithm and the flowchart, followed by implementation using C programming language. After that, we tested a simulation to observe job order and key performance metrics like waiting time and turnaround time. Finally, we documented our findings and compiled the code.
The hardware requirement and software requirement. For the software, we just need a C compiler. For the hardware, any laptop or PC with at least 4 gigabyte of RAM and being a multi-core CPU. And for the distribution, me and Goh Chang Zhe did the report writing, and I did the C implementation and flowchart design, while him doing the test debugging and literature review.
This is the system flowchart of our office printer queue simulation using the shortest job first scheduling algorithm. The process begins by starting the printer queue management system. We initialize all print jobs with their ID, page count, and arrival time. Each job's print time is calculated using the formula pages times 2, assuming 2 seconds per page. Next, the system displays the initial job queue before sorting. Then, all jobs are sorted using non-preemptive shortest job first, giving priority to jobs with shorter print times. After sorting, we display the updated job queue. The simulation then initializes tracking variables like current time and job completion count. It checks whether all jobs are completed. If so, it displays the summary table with job details and average performance metrics. If not, it searches for the shortest job that has already arrived but isn't completed. If one is found, it calculates the start time, finish time, waiting time, and turnaround time, then marks it as complete. If a job is not ready, the system marks the printer as idle and increments the current time. This process continues until all jobs are completed and the final results are shown.
For our implementation part using C program, The first of all, we initialized a struct. This struct contained all the PCB values for each printer job, like the page ID, arrival time, print time, start time, finish time, waiting time, turnaround time, and completion time. So, and then we had the shortest sort by shortest job first function, which used to sort all the PCBs by the one with having the shortest completion time or shortest job time that's needed. And also we have a separate function which is just to set the print time, which basically is indicated 2 seconds per page. It calculates 2 seconds per page, so it's 5 pages, it will multiply by 2, so it will be 10 seconds. In our main function, we initialize all the job struct using like hard-coded jobs, and then afterwards we display the documents in the buffer, showing the initial documents in the buffer and the one after the short job first function being called. So this is the main buffer loop. Basically, it first of all it monitors the buffer, seeing which job arrived first, and then giving when it collects the information about which jobs have arrived now, and choose the one with having the shortest job completion time or shortest print time job. When the printer is available, it processes the selected job until the completion without interruption or non-preemptive. If no eligible jobs are in the buffer, either one have arrived or all jobs are completed, the printer enters an idle state. The system track performance metrics, including like the waiting time, round-around time, to evaluate scheduling efficiency. This implementation showcases the basic printer spooler that balances job arrival time with processing requirement to optimize printer utilization. And finally, this part of the main function, it shows and outputted the summary for the all the buffer jobs after it have been completed. It shows the ID, arrival, pages, print, start, finish, and waiting and turnaround time for the whole process, and also it showcased the average waiting time and the average turnaround time. These statistics help in providing quantitative measure of the shortage of scheduling algorithm efficiency. Lastly, as you can see here, this is the output of the program. It shows the initial job queue, which is what we hard coded in, and the sorted by shortest job first, which now chooses the one that has the shortest job and put it at the head of the buffer, at the beginning of the buffer. And it also shows the printing log, what happened in real time, like for example what's been done at 35 30 seconds, 40 seconds, 60 seconds, which document have been printed, which and how long it took. And at the end it shows a summary of each and every printing job, when it started, when it ended, and the waiting time and the turnaround time it took, and finally the average time.
This is the future work and conclusion of our project. For future improvements, we plan to implement the preemptive shortest job first algorithm to better handle real-time job arrivals. We also aim to compare shortest job first with other scheduling methods like priority scheduling and round robin to evaluate their performance. To enhance user experience, we hope to develop a graphical user interaction for better visualization and interaction. Additionally, supporting real-time job monitoring and allowing dynamic job addition will make the system more practical. Finally, extending the simulation to support multiple printers can help with load balancing and improve efficiency in larger environments. In conclusion, our project successfully applied the non-preemptive shortest job first scheduling algorithm to an office printer buffering system using C programming language. By prioritizing shortest job, the system improved queue responsiveness and reduced overall wait times. This simulation shows how operating system scheduling techniques can be applied to real-world scenario to optimize resource management and task performance.
Hi everyone, today we are pleasant to present our project titled Airline Boarding with Priority Scheduling. This presentation is brought to you by Heng and myself, Yee Hao. Together we explore how operating system concept, specifically priority scheduling, can be applied to real-world challenges such as managing airline passenger boarding more efficiently.
Hi, Doctor. I'm Zhuo Heng. This is abstract of this part of project. So this part of project simulate the use of priority scheduling commonly used in operating system to optimize the boarding sequence at an airport. So we categorize the passengers into crew, business, family, and economy classes, each with descending priority levels. So by using the C++, the program demonstrates how higher priority group board first regardless of arrival order. We also visualize the process using color-coded output and time delay. So this work highlight how scheduling algorithm can model real-world system and support the design for more efficient boarding procedures. This is the introduction of this part. In airport, managing boarding sequence efficiently is crucial to avoid delay and improve the passenger experience. So we inspired by the process scheduling in operating system. This project apply the priority scheduling algorithm. So this simulation aim to visualize how passenger with higher priority, like crew, business class, are given boarding preference over others.
Now I'm going to present a problem statement. Traditional boarding methods often cause delays, crowding, and passenger dissatisfaction due to the lack of structural priority. Our project addresses this issue by implementing a non-preemptive priority scheduling system inspired by operating system concept. In our simulation, passengers are divided into four categories: crew, business class, family, and economy, each assign a descending level of priority. Using C++, we model this system so that higher priority passenger board first, regardless of their arrival time. Our goal was not only to simulate a boarding process, but also to demonstrate how computer science algorithm can solve real-life problems such as airport inefficiency. For the related works, priority scheduling is widely used in computing such as CPU task allocation. It also applies in real-world systems like hospital, triaging, and traffic control. Our project extends this concept into the airline domain, showing how flexible and adaptable scheduling algorithm can be.
This is the project management flowchart. We start with project planning. We identify the problem, scope, and objective of the airline boarding simulation. Followed by literature review, we study the priority scheduling algorithm and its real-world application. So after that, we do the system design and then implementation of the C++. After that, we do the testing and analysis and also documentation.
This simulation was developed using C++17, compiled using code blocks or G++, and tested on a standard laptop with at least 4 GB RAM and a multi-core processor. The work was divided between two members. Heng focuses on literature review and testing, and me, Yee Hao, handle the flowchart design and C++ implementation. Both of us contribute to the final documentation.
This is a system flowchart. This flowchart represents a priority-based passenger boarding process used in systems like airport boarding or event entry management. So at step 1, the boarding process starts. Step 2, the system initializes for queue for crew, business, family, and economy passenger based on their priority. So at step 3, the system check if all queue are empty. If they are, the process end. So if not empty, the system check the crew queue. So if the crew queue is not empty, the crew passenger are boarded first. Then the system check all queues again. So if crew queue is empty but business queue have passengers, they are boarded next. So at step 6, if both crew and business queue are empty, the family group is checked and boarded if not empty. At step 7, if only the economy queue have passenger left, they are boarded last. So at step 8, once all queue are empty, the boarding process ends.
Now I'm going to talk about the code implementation. The code is structured into six main parts. The first part is passenger struct and helpers. This hold each passenger name and priority. We use A and SI codes to display passenger in different colors for better virtualization. Second part, initialization. We create a mixed list of passenger and shuffle it to simulate a natural arrival. Part 3, categorization. Passengers are sorted into their respective queue based on their priority. Part 4, initial display. The program shows the shuffle boarding list with virtual indicators. Part 5, main boarding loop. This is where the simulation boards each group in priority order with a 1 second delay to simulate real-time boarding. Part 6, final output. The system displays the final order of boarding, clearly showing the effect of prioritization. Now I'm going to talk about the result and discussion. From the result, is clearly that priority scheduling ensures a more structured and faster boarding process. High priority groups were always boarded first, regardless of arrival sequence. This confirmed that our non-preemptive scheduling logic worked effectively in simulating real-life boarding scenarios.
So this is the future work and conclusion. First, I will talk about the place that we can improve in future. So the first one is preemptive priority simulation. So we can introduce real-time events such as arrival of urgent passengers like pilot to simulate the preemptive scheduling. So the second one is data input system. We also can implement user input or file-based passenger list to make the simulation more interactive and dynamic. And the third and the last one is graphical interface. We also can develop a GUI-based version using C++ framework to enhance visualization and user engagement. So this project successfully demonstrate how priority scheduling can be applied to model airline boarding procedures. By simulating the boarding order in non-preemptive fashion, this project reinforced key concepts from operating system and showcased their real-world relevance. So this simulation also serves as a foundation for more complex system where scheduling efficient is critical.
In conclusion, our project shows how priority scheduling can improve the efficiency of airline boarding by giving structured priority to different passenger groups. It highlights how operating system concept can be applied to real-world situation. That's all from us. Thank you for your time.